Okay, so the first thing it says is the graph of the function at the next picture to the right. It's not really, it's pictured underneath, but it says to factor it and use the factors to find the zeros. So go ahead and factor over us. It's just like what we've been doing, so, and we've been factoring forever and ever, so it should be pretty easy. It has a GCF of x. So I factored out an x. Factors further than that is this trinomial factors as x plus 3, x minus 2. Finding all of the zeros. Remember, each piece, we've now factored this into 3 separate pieces. The x plus 3, and the x minus 2. Each piece gets set equal to 0. So x equals 0, x plus 3 equals 0, and x minus 2 equals 0. So the last two pieces have to be solved. So I have 3 zeros. 1, 2, 3. Now, if you look at the picture, you can see all 3 of those zeros. There's -3, there's 0, and there's 2. Right there on the graph. Also, if you remember, the fundamental theorem of algebra says that whatever this exponent is, the highest degree, tells you how many zeros you should end up with. So it's a cubic, it's to the 3rd degree, so I should have 3 zeros, and I do. Okay, so then the next thing it's asking me is to identify where the following things are true. The first thing it asks is where the function equals 0. Well, we already identified the 3 places that the function equals 0. It equals 0 at x equals -3, 0, and 2. The next question, where is the function greater than 0? That would be where it is above the x-axis. It's above the x-axis in 2 different spots from here to here, and then again here. Now, it just asks me above. It does not say where is it greater than or equal to. It just says where is it greater than. So no brackets this time. It's greater than from -3 to 0. And then again, so in union with 2 to infinity. The next question is where is it less than 0? Not less than or equal to, but just less than. So it's less than on this first piece, going from -infinity to -3. And then it drops below again at 0 to 2. Now the next question asks me, where is the graph greater than or equal to 0? So now the interval doesn't change, where it's above the x-axis. The only thing that changes is now you'll actually have brackets because it has that equal to sign underneath. So it is greater. It's actually equal to at -3, so that gets to be a bracket, to 0, in union with 2 to infinity. That one still has to be in parentheses because infinity can't ever be a one. Same thing for less than. It's less than here from -infinity, that has to stay in parentheses, to -3 where it equals, that's a bracket, and then again from 0 to 2. Both of those are brackets. Now they've given us a new function. It is pictured down here on the bottom right. Factor g of x and use the factors to determine the zeros. Now looking at it, again, if I look, the fundamental theorem of algebra says that whatever the highest degree is how many zeros I should have. I should have 3. If you look at the graph, you have 3. You can identify all 3 of them. So now let's factor it and see if we can find out exactly what the 3 are. Because if you look at your graph, 2 of them are between the actual hash marks of the grid lines. So I'm going to have to see if I can figure out what those are. So I'm going to factor this. In this case, it's going to be factoring by grouping. Because I have 4 terms. So remember, when you have an even number of terms, you can factor by grouping, or at least try. Make sure it's in the right order. It is. So I group the first 2 terms to the last 2 terms. And then you take a GCF out of each piece. When you do that, remember what's in your parentheses needs to match, which it does this time. I have an x plus 3 in both sets of parentheses. That becomes your GCF. So pull it to the front. And if I factor GCF out of this piece, I'm left with x squared. And then if I factor it out of this piece, I'm left with minus 2. Now, for just a moment, I look at this x squared piece and think, oh, well, that probably factors further. But they are not both perfect squares, so it does not factor any further. So we just move to the next step, which is to set each factor equal to 0. So I have 2 factors here. Each one gets set equal to 0. X plus 3 equals 0, and x squared minus 2 equals 0. So x equals negative 3, and on this one I have x squared equals 2. I'm still not quite finished, because you have to take the square root of both sides in order to get just x. So I get x equals positive and negative square root of 2. Now, square root of 2 is an irrational number. You can put it in your calculator and you can get a decimal. It's kind of a nasty decimal. It's 1.41, etc., etc., etc. It's like pi. It goes on forever, doesn't it? So I'm going to leave it as the square root of 2. But I do know when I'm looking at my graph that this over here is the negative square root of 2. And this one right here is the positive square root of 2. Okay, so they asked me the same question again. Where does g of x equal 0? Well, g of x equals 0 at x equals negative 3, negative square root of 2, and square root of 2. Next question asks me where it is greater than 0. Not greater than or equal to, just greater. It's greater right here in this one little bump, and then again at the end. So from negative 3 to the negative square root of 2 in union with positive square root of 2 to the 5th. Where is it less than? Well, that's this piece and then this piece right here. Negative infinity to negative 3 in union with negative square root of 2 square root of 2. Where is g of x greater than or equal to? So above or equal, so I've got some brackets this time. Bracket negative 3, negative square root of 2 bracket. And then 5 asks where it's less than or equal to. So negative infinity to negative 3 is equal at negative 3, so that's a bracket. Bracket, negative square root of 2, square root of 2. Okay, so far so good. This is kind of combining a lot of different things that we've already done. Alright, so now we are going to develop an algebraic analysis method that's going to enable us to solve a polynomial inequality based on what we've just done. So now we're moving from just having the function and a graph to an actual inequality. So it says complete the factored given polynomial provided that it's not already factored. Now it isn't already factored, however we just factored it on the page before, so it should be pretty simple to factor this real quick. Factor out an x, that gives us x squared plus x minus 6. We factored this on the page before. It comes out to be x plus 3, x minus 2, and set each factor equal to 0 and find the zeros of the function. Again, we did this on the page before. We know that x equals 0, x equals -3, and x equals 2. Now, this part we did not do on the page before. Draw a number line that is divided into segments using the zeros that you found. So there's -3, 0, and 2. Alright, now we've done something very similar to this when we did absolute values and rewriting them as piecewise functions. We are going to choose a number from each interval, so a number that's in this area, then one that's between these two, and then in this area. And we are going to determine the sign of each factor of the polynomial based on the chosen value. You do not have to figure out actual numbers. All we're trying to determine is whether or not things would be positive or negative in that region. So, you just go piece by piece. So in this case, when I factored it, I factored this into 3 separate pieces. So I just need to determine whether it's positive or negative for each piece. So I'll show you what I mean. For this first area, right here, let's use -4 as our number. Well, if I plug a -4 right here for x, that little piece comes out to be negative. So I'm going to write one little negative sign in instead of parentheses. If I plug -4 in this piece will come out negative. And if I plug a -4 in this last piece, it also comes out negative. Well, 3 negatives, a negative and a negative, these first two will become positive, but then you multiply by another negative. This entire region is going to be negative. Alright, now I'm going to do it again, but this time I'm going to use a number between -3 and 0. Let's just say -1. So if I plug a -1 right here for x, that piece is negative. If I plug -1 right here, -1 plus 3, that piece would come out to be positive. If I plug a -1 in this last piece, it would be negative. Well, a negative and a positive and a negative. 2 negatives makes a positive, and I already have a positive. This entire region comes out to be positive. Okay, let's do it again. This time between 0 and 2, I'm going to use 1. I'll plug a 1 right here, that piece comes out positive. Plug a 1 right here, that piece comes out positive. If I plug a 1 right here, that piece comes out to be negative, which means this whole region is negative. Last, I'll use 3. Plugged in the first spot, that's positive. Plug in the middle, that's positive. Plug in the last, that's positive. So this whole section is positive. Alright, so we just chose a number from each interval, we determined the sign. This enables us to determine if the entire polynomial is positive or negative in each interval. So we've determined what happens. Now, refer to the original inequality sign. So I go back up and I look, and it is greater than or equal to 0. So now I just have to look at my region